Hello, my name is Pamela Kuther, and I am an instructional specialist for secondary mathematics with Richmond Public Schools. Welcome to the Richmond Public Schools Distance Learning Modules. In this series, we will learn Algebra 1, where we will focus on different SOLs each week. This week, our focus is SOL A.1b, Evaluating Expressions. Today, we will review the order of operations. Before we get started, you will need a few supplies: your interactive notebook or a few sheets of paper, a pencil or other writing utensil, and access to the Desmos graphing calculator. This can be downloaded as an app on your phone or other electronic device, or you can simply connect to it through the link. Before we learn our skill for today, we need to familiarize ourselves with a few vocabulary terms. Please copy the vocabulary terms, any illustrations, and definitions into your notebook. Just as a reminder, the order of operations tells us the order in which we should simplify expressions. We use the first letter as G because it stands for grouping symbols. Many of you have heard of PEMDAS, where the first letter is P. Here we use G because we want to have that applied to all grouping symbols. Now we are ready to look at our instructional video, which is where we will have our skill explained to us today. Before we start, please open the notes. Copy the notes and fill in the blanks as you watch the video. The video is also linked in the presentation.
So you want to know about the order of operations? Well, the first thing to know about the order of operations is that it's the steps we follow in order to simplify or evaluate an algebraic expression. The second thing to know about the order of operations is it's important. How important, you ask? Well, think about an everyday task, like putting on your socks and shoes. Now reverse that order. Shoes first and socks second. Doesn't make a whole lot of sense, does it? Plus, people might stare if you leave the house. So just like putting on socks and shoes, order in the order of operations is important. So let's learn it. Our first step in the order of operations is to evaluate grouping symbols. Grouping symbols include any brackets, parentheses, or fraction bars you might have. Now you want to make sure to evaluate these grouping symbols from the innermost one to the outermost one. Our second step is to evaluate any powers. So anything that's raised to a power needs to be simplified in step 2. Step 3 is to multiply and divide. You want to do this the same way that you would read a book, from left to right. Now our fourth and final step is good old adding and subtracting. We want to do this the same way that we multiply and divide, from left to right. So now that we know the order of operations, let's take an example. Once where we use the order of operations correctly, and once where we don't. Let's do it right the first time. Okay, if we evaluate this expression using the order of operations, what's our first step? Grouping symbols. Exactly. Take the parentheses, and we want to simplify whatever's on the inside. So 2 plus 3 becomes 5. Our second step is to evaluate any powers. So 3 squared becomes 9. Our third step, multiply or divide from left to right. So we get 45 plus 5. Last step, add and subtract from left to right. 50, the right answer. We used the order of operations correctly and got the right answer. Perfect. Now what happens if we evaluate the same expression, but we don't use the order of operations? Let's see what happens. Rather than doing grouping symbols first, let's ignore them. Let's add 3 plus 5 together. We get 3 squared times 2 plus 8. Already looks kind of different than what we had before. Well, let's multiply these two together. We get 6 squared plus 8. Now evaluate 6 squared to get 36 plus 8, and add the two together to get 44. Ooh, 50, 44. We didn't use the order of operations, so we got the wrong answer. So, order in the order of operations, know it and know it's important.
Now that you've learned the skill for today, we will look at some model examples. Please complete and copy the examples in your notebook. Also, feel free to jot down any information said throughout the explanation. Here our example is square root of 9 plus 16 minus the quantity 8 minus 3 squared. We must use the order of operations to simplify this expression correctly. Just like in the video, if you do the steps out of order, your answer will come out incorrect. Here are two ways to do this problem. On the left, you see where I've done the problem by hand, simplifying the 9 plus 16 under the square root, and that gets 25, and then doing the square root of that gives me 5. Then I do the quantity inside the parentheses, 8 minus 3 squared, doing the exponents first, and then subtracting. And then I bring it all together and get an answer of 6. Now I will show you how to use the decimals calculator to do the same expression. Now let's look at model example number 2. Notice here that we have 5 possible answer choices. Here we have this expression written in rational form, meaning that it's written as a fraction. Let's look at 2 possible ways to simplify this expression. On the left, you see where I've simplified the expression by hand, simplifying the numerator first, and then the denominator, separately, and then bringing those together at the end. Notice in the next to last step, I did simplify the fraction by dividing the numerator and denominator by 3. Let's look at how we can enter this same expression into the decimals graphing calculator. Now that we looked at some model examples, now it's time for you to try one on your own. Notice the hint on the left side of the screen. Write out GMDOS and cross out the letters as you complete each step. Remember what the instructor said in the video, to work the grouping symbols from the inside out. So inside the brackets, you want to make sure you work the parentheses first and then work your way outward. Let's look at the solution by hand. Notice here that I started with the innermost grouping symbols, the parentheses 3 squared minus 12. I squared the 3 and got 9, and then minus the 12 and got negative 3. Continuing to work my way outward, I times that by the 4, which gave me negative 12. And then inside the brackets, I have 6 minus negative 12, which we know minus a negative is the same as addition, which gives me 6 plus 12, and that gives me 18. Plus the square root of 169, which is 13. Notice I did that back in the first step, and since I was not able to do anything with that, I just continued to bring it down to the next step, until the end when I was able to combine it with the 18 for a final answer of 31. Let's look at how we can do this same expression in the Desmos calculator. Remember that you will always have access to the Desmos calculator, so feel free to use it as often as you like. This concludes our lesson for today. During your remaining work time, please complete the practice problems as well as the online practice. The answers to the practice problems will be in tomorrow's module. Enjoy the rest of your day and stay safe.